تمام، خلاص راح أبدأ الآن. Good evening, everyone. My name is الوزرة. It's a great honor for me to be with you
هل أبدأ
today.
الآن؟
I would like to thank everyone for coming here and special thanks to Sadaf for inviting me. We would like to welcome Dr. Sarah Al-Hamoud for coming as well. Our topic for today is about sentiment analysis using deep learning GRU for Arabic tweets.
خلاص راح أبدأ الآن.
In this presentation, we will present the introduction to sentiment analysis and also sentiment analysis using deep learning techniques.
Good evening, everyone.
We will view the proposed model, which are SGRU, S by GRU, and also the ensemble model that is contain SGRU, S by GRU, and transformers. Also, we will present the experimental results and finally the conclusion. In the last decade, social networks become the main resource to gather information about people's opinions about different topics. And sentiment analysis is required to give us a general insight about these different topics. And focusing on the Arabic, as we know, around 10 years ago, almost all written contents are in modern standard Arabic. It's a recent challenge to analyze these opinions, especially when we deal with modern standard Arabic and dialect tweets. So to implement the sentiment analysis model, we have to specify the techniques in which level and specify the word embedding as well. So sentiment analysis classification can be applied at the document, sentence, and aspect level. We use the word embedding because we want to represent the words in any dataset as a real value vector. So it can be fed in the neural network model. That means that the words that have the same meaning will have the similar representation. Regarding the techniques, there are 3 core techniques for sentiment analysis system. We have machine learning, we have lexicon-based, we have the hybrid method that use both machine learning and lexicon-based. We are focusing here on the deep learning, which is a machine learning techniques that use a neural network with multiple deep layers for data processing, and thus it learns complex features from simpler features. The neural network may become feed-forward, recurrent neural network, hierarchical, or hybrid. And here we will focus only on recurrent neural network, especially with GRU and by GRU with the notion of stacking. Unlike the general model architecture, which is many to sentiment analysis using multiple input and one output. Here, this is the general model architecture for models, which is SGRU and S by GRU, and also the ensemble model. But here we will start with SGRU and S by GRU model architecture. So as you can see here, this is the general model architecture for SGRU and S by GRU. We pre-process the tweets to discard any noise that may affect the training process.
ما أدري في صوت ولا اختفى بس من عندي. في صوت.
في أحد سوالي ميوت. مو مشكلة. وين وقفنا الحين؟ يطلع لكم العرض؟
هو بس
تمام. طيب، إحنا قلنا هنا unlike the general model architecture, which is many-to-many, sentiment analysis model generates only one output or one class. So it is many input and one output. We will propose two models, which is SGRU and SByGRU, and also the ensemble model. So we will start with SGRU and SByGRU. So as you can see here, this is the general model architecture of SGRU and SByGRU. In the first, we pre-processed the dataset to discard the noise that may affect the training process. And then we fed the pre-processed model or tweets into Arabic. We use Arabic to generate the embedding vector. And then we separate the dataset into training data and testing data or validation data. We will use the training data to train our models, which is SGRU and SByGRU. We use the validation to check the actual sentiment after training. So we will explain each point in the next slides. Here we use a recently new dataset named ASA dataset with total of 56,674 tweets from different domains, which is news, politics, and sports tweets. And it's manually classified as positive, negative, and neutral. And the ASA dataset being one of the largest corpora in Arabic tweets with sentiment labeling. Here we did some pre-processing on the dataset, including decoding HTML encoding and remove duplicated tweets. We also clean unrelated contents. We also remove all digits, non-Arabic words, and duplicated characters. We also normalize some letters. Also, we will study this point, which is point number 6. We will compare between hashtag stop words and auto-generated stop words. And the best method will be used with the previous pre-processing. The last one is we take the pre-processed tweets to tokenize it into separate words. As we said regarding point number 6, we will compare between these techniques, which is removing hashtag, removing stop words, and automatic generated stop words to choose the best techniques to be applied with other pre-processing techniques. As we can see here, we have the 3 points to be compared, which is removing hashtag, removing stop words, and automatic stop words removal. We know what we mean by removing hashtag. In the second point, removing stop words, we have manually collected 689 stop words we collected manually. The third method is using auto-generated stop words. As you can see in this table, we apply the frequency of each word and how many times these words appears in positive, negative, and neutral tweets. The idea behind the auto-generated stop words method is that some words are appeared almost equally in positive, negative, and neutral tweets, as you can see here in this table. For example, let's take the word al-hilal. We can see that this word appeared around 8,000 times in negative tweets. It appears 10,000 times in positive tweets, and it appears around 4,000 times in neutral tweets. So the automatic stop words removal will classify each word based on its frequency. So the automatic stop word will classify this word as positive because it appears almost in positive tweets. Note that it will classify the words regardless the actual sentiment of these words. Let's take another example, which is al-ahli. This word will be classified as null because, as you can see here, it appears almost equally in all classes. So the automatic stop word will use all null words as a stop word list. So as I said before, the automatic stop word removal will classify the words regardless the actual sentiment. But this method could help us to discard noisy words that appears equally in all classes. For word representation, we will compare 3 Arabic pre-trained embedding. We compare Arabic with fast text and Arabic news. With this source and vector size with vocabulary size in each one. We use, as we said before, we use the word embedding to learn rich semantic information and rich contextual information effectively. So for the modeling, we will start with the stacked GRU architecture, and here we will fit the embedding vectors to the model. Here we stacked several GRU layers, and as you can see here, each hidden state will be calculated using the previous hidden state from the previous time step, and also the previous time step from the lower layer. So this process will appear in each hidden state. So as I said, we stack several GRU layers above each other. In the stacked by GRU layer, at least 2 forward layers and 2 backward layers are stacked above each other. And as you can see here, these are the embedding vectors. And these embedding vectors will be passed in the first forward layers and the first backward layers. And we calculate the output based on the last backward layers and the last forward layer with a use of concatenation. Since we have the output, we can calculate the sentiment prediction for each tweet by using the last output as an input to calculate the softmax and specify the tweets class. Now we have finished the model architecture of SGRU and SByGRU, and we will start presenting the ensemble model architecture. As you can see here, the ensemble model is based on 3 models, which is SGRU, SByGRU, and Arabert. So Arabert is one of the Arabic versions of BERT, which applies the attention model to language modeling. And this type of training can have deeper sense of language context and flow than the single direction language models. And it's a recent trend in natural language processing tasks to use the transformers. So here we pre-processed the tweets as we mentioned previously, and we fed these tweets to each model here, which is SGRU, SByGRU, and also Arabert. And finally, we use the voting to generate the last predicted label for these model results. Now we will present the experimental results. As you can see here, we compare between different embedding, which is Arabic, fast text, and Arabic news. So as you can see here, the Arabic, which is in the green line, outperformed better than all other embeddings. That's why, because it used the Twitter domain for the modeling, the embedding layer. Here we compare 3 pre-processing techniques, which is removing hashtag, stop word removal, and also we compare it with automatic stop word removal. So here we use the basic pre-processing as a benchmark for comparison. And we can see that the comparison is based on cross-entropy loss during each epoch, which has 5 epochs. Of course, lower loss means better prediction and more precise class label. So we targeted the lower. So as you can see here in the purple, we can see that the basic pre-processing with automatic stopword removal perform better compared with the other pre-processing techniques. And of course, sure, if we increase the number of epochs, we will get lower loss. For both models, we can see that the accuracy has increasing with the layers increasing because the addition of layers get additional extracted feature from the model. Also, we can see that S by GRU outperformed the SGRU in terms of recall and F1 score, while SGRU outperformed S by GRU in terms of loss and training time. Here we compare between all models with the ensemble model. So as we can see here, the performance of GRUs, SGRU, and S by GRU is comparable with much powerful machine learning technique, which is SVM. Also, the Arabert, as you can see here, is successful because it used the excellent representational power of transformers. In terms of the ensemble of the best of model, this newly proposed model achieved 90% accuracy. As you can see here, it achieved 90%. The ensemble model is more accurate than its individual components because within the classification context, the individual components generate different decision boundaries with independent errors are produced by each classifier. And combining these errors usually reduce the total error. Because we know that every sentiment classification has its advantages and disadvantages, and the overall accuracy of many different sentiment classifiers with majority vote or mode gaining better accuracy using the ensemble model. In conclusion, we proposed SGRU model, S by GRU, and also the ensemble model that contains SGRU, S by GRU, and Arabert. Also, we presented the automatic stopword removal, and we found that we gain 8% in loss decrement and 3% in accuracy increment. Also, we compare different embeddings such as Arabic, fast text, and Arabic news, and we found that Arabic is effectiveness compared to fast text and Arabic news. Also, SGRU and S by GRU are comparable with much powerful machine learning models such as support vector machine. Also, we found that the SGRU and compared with S by GRU, the accuracy increased when we increased the layers. Moreover, we found that S by GRU outperformed SGRU in terms of recall and F1 score. In addition, SGRU outperformed S by GRU in terms of training time and the accuracy. Finally, the ensemble model outperforms all singular models. In feature scope, we try to enhance the automatic stopword removal. We try to enhance the transformer along with RNN techniques. And in addition, we try to specify the recent trends in classification, such as emoji, sarcasm, and cyberbullying, because it's challenging to analyze the exact sentiment. And we will try to use our model with these trends. Regarding the challenges, we are facing some challenges during the work. We faced writing challenges because we found that several papers have published during the thesis preparation. And also we expand the idea with recent techniques such as the transformers. Also, in the implementation challenge, um, a lot of experiments have been done for pre-processing phase to find the suitable steps. Also, we has challenge with the Keras and TensorFlow version. We try to unify the version to implement both SGRU and SByGRU. And a lot of implementation challenges, such as we found some codes in Java, we try to transform it to Python. And also we spend a lot of time to find the best configuration. Also, we enforce to keep the epoch equals 5 because we use Google Colab, and the number of models implemented enforce us to keep the epoch size equals 5. Regarding life challenges, I gave birth of my second child during thesis. I tried very hard to manage my time so that no one is neglected during my journey. Also, I became a volunteer in King Faisal Specialist Hospital so I can gain experience and work on tools and real data full-time for 4 months with no salary. I was trying to publish research papers. I spent a lot of time on my laptop doing my work, so I have to give special thanks to my children. I know I love them a lot, but the result deserve. Thank you so much for your listening. If you have any question, please write it down in the chat box. Thank you so much. الله يعافيك.
السلام عليكم.
وعليكم السلام.
يعطيك العافية أستاذة أسماء، جهد جبار وواضح التعب اللي فيه. إن شاء الله ما يبقى لك تعب.
الله يعافيك.
أبي أسأل بالنسبة للأرابرت، هل تم عمل فاين تونينج؟
أيوة، قصدك الconfiguration, right?
إيه.
Yes, yes, we apply it.
تدرب على الداتا سيت يعني؟
Yes.
وهل في مثلا open source الكود؟
Yes, I can provide you the link in GitHub so you can see it.
حلو، يعطيك العافية، شكرا.
الله يعافيك.
لا خلاص، شكرا جزيلا.
صحيح.
أكثر الوقت راح لأني كنت أحاول أنشر papers. اشتغلنا على 2 papers, one of them under process, and the other one is published in the Artificial Intelligence Review, which is a Q1 journal with impact factor of 5.7. So الحمد لله نشرت في أبريل الماضي وتقدرون توصلون لها إن شاء الله. الله يعافيك. لا بس في حاجة بقولها اللي هي عنوان الورقة يمكن تشوفون منها الاستزادة اللي هي Arabic Sentiment Analysis using Recurrent Neural Networks review. It will provide a review of all recurrent neural network approaches, specifically in sentiment analysis in Arabic. So you can find all 30 studies that we mentioned before. So I hope you read it and you get benefit from it. Yeah, I can provide. إن شاء الله تمام. الله يعافيك. الله يعافيك. الله يعافيك وشاكرة لكم استضافتي. الله يعافيك. شكرا. مع السلامة.